Data is everywhere. It's our responsibility to keep up with how we protect it and what we can do with it. When asking ourselves why we need a master data plan, we should look at what has worked and what has not worked. Master data management is necessary because companies are having problems adapting to massive changes. There are some organizations who fail to manage how their data is stored and where it could be best used to address certain problems or come up with different solutions. It will also help make data-driven decisions that will have stakeholders and management better informed about the situations they have encountered. Keeping up with the structuring of data is an issue that is not addressed effectively and often comes without a solid strategy to keep data organized. Our analysis will provide several models that would help companies organize their data in ways they can get value out of as much information they have collected as possible. Change is always a constant. Thus, master data management is necessary because users will ask different questions and experience various levels of complexities. Companies are experiencing increased interest in data and using it to improve in their capabilities and decision-making. Data management holds to have a system in place to assure that all users working with this data comes from one and only one primary source. In today's era of technology, change is constant, but the rate of change is rapidly increasing. A proposal is required to determine if either one or multiple data models are needed. Should more than one model be required to keep up with demands of data, it should be done to ensure a smooth transition between any one type of model while maintaining the legacy of a previous model. There are different patterns and situations that require decisions to be made to attend to any investor's needs, but a robust system will need to be in place to assure an organization of needing an architecture that will prove beneficial to prioritize data and the capabilities that come with utilizing it in practice. The desire for a single version of the truth is needed for a company to constantly check that the data they are working with is up to date and authentic to the core. There will be 5 different master data management models that we will be looking at. A business should strategize why they will need a master data management plan in mind to know what data they are working with and how they can get the best insights from it. The 5 models to focus on are the following: Star Schema, Third Normal Form or 3NF, Master Data Management Hub or MDM Hub, Snowflake Schema, and Data Vault. Each model will be analyzed for its benefits and consequences, then will be compared with each other for which models lack what others already have. I am requesting approval to move forward with at least one data model to be implemented because it will help a company understand how to manage its key assets and information. It promotes planning a data model for today and for the near future, and where and how to adjust to different kinds of changes and demands wherever necessary.
The first master data model that will be covered is the Star Schema. The Star Schema is the easiest dimensional model to determine entity relationships, how data is stored, and provides a comprehensive view of how data is organized. It is the most popular in initiating a master data management project for an organization of any given size and can be used to structure data they have. Author Ralph Kimball suggested that this design is the best for business intelligence and online analytical processing, among other hands-on activities with data. This model emphasizes quantitative data to be stored and is placed at the center of the star. Additional dimensions provide support as other attributes further describing key data at the central point in this diagram. It is dimensional, where data is grouped based on the facts and dimensions, and is appropriate for a general understanding of the data available that will be used to achieve the desired task or goal at hand. While the model appears to be archaic and out of style with technology upgrading at fast rates, this model is still widely accepted in industry because it forces users to have a general understanding of how their data is structured whenever they work with it. This model has been in place for at least 30 years, but has proven its usability because there are categories that allow the data to be broken down into different groups. On the right is an example of what a Star Schema data model will look like. In this case, it is an entity relationship diagram with 2 dimensions. The operation table is at the center of this star and is the first dimension, and the patient, diagnosis, clinic, and data tables are attributes of the second dimension. On paper, it identifies the keys and values and the tables they belong to. The primary value of the star schema is its scalability that allows users to find what they want, even if it means working with any volume of stored data. Another value that can be useful for the star schema is the balance that users can set between normalization and denormalization of the data at the levels they prefer. This is very helpful for those in analytical work where they require business intelligence tools and using data to produce solutions. While there may be regular maintenance needed, the star schema has proven to be a stable master data model because of its simple structuring against changes made. Something that's not valuable with the star schema is for anyone looking for a model with fewer dimensions, because data in analytics will grow dynamically and have complexities in its growth and stability. Another value not useful for the star schema is duplicate data, because data can overlap with every new change made. Thirdly, the quantity of dimensions will change rapidly over time, and such a schema is not suitable for big data projects. The larger the amount of data in the system, the slower the processing and retrieval speeds are in getting data. The next master data model we will be covering is the third normal form style. 3NF is a normalization style focused on starting the minimalization of the data redundancy found throughout a database. First introduced by Edgar F. Codd, data is to be built off different kinds of relationships and is the best model for systems directly working with customers and their transactions. A third normal form model does not have any non-key interdependencies when attributes under an entity can be removed from its original entity and separated into its own table. Users, however, are responsible for detecting and implementing changes to make the data in the system as unique as possible, which applies to key values and their associated attributes. This uniqueness is required in 3NF because it will provide users a better understanding of what data they want to see, instead of searching through tables of attributes for data they don't need. They want data that matters the most to them for findings or trends that are new in certain attributes, which could be helpful for analysis or research. This 3NF model on the right shows what not to do and what to do with data that can be made into its own table. The violations seen under the student table can be made into its own table. To correct this, the new 3NF model shows there is a table called department with department information that was once under student. While new data can be inputted in real time with this model, users are responsible for acting on changing dimensions to restructure data and look for attributes that can be their own entities or tables. One value of the MDM Hub is its variety of options that can be implemented. Users are responsible for catching any mistakes and forces them to think immediately on issues with the structure or how data is situated. This model then forces any obvious redundancies to be removed at any stage of this normalization form. It also allows users to view and assure themselves of the data that is changed in real time. 3NF may not be helpful because there are higher degree normalization forms that users may choose to apply to their data. Some may choose to dive right into more complex normal forms to assure that data is unique. There are slower processing speeds for more data coming into a system, where querying speeds also slow down going through different tables. Furthermore, there are higher costs for data management and applying any applications or tools to store or work with data. The MDM Hub is another data model that integrates software tools inside a database to keep all the data updated. There exists one central reference point where organizations can access and understand what the single version of truth is when making data-driven decisions and solutions. There are different kinds of MDM hubs that will best satisfy users' needs for overall presentation of data and its retrieval. Four of the most notable MDM hub styles are the following: registry, consolidation, coexistence, and transaction. The type of MDM hub that a company uses depends on the kind of data that a company or organization is working with. Out of the four notable MDM hub implementations, the transactional style appears to be the most straightforward because the single version of the truth is heavily emphasized, where the data is always updated. Each style best satisfies users' needs for overall presentation of data and its retrieval, but also depends on the kind of data that the company uses. This image is an example of the MDM hub in the transactional or centralized style. Industries such as retail or finance would find the style of the hub helpful because the applications and sources meet up with their needs where data is constantly being updated. One value of the MDM Hub is its variety of options that can be implemented, because there are different MDM Hub styles dependent on the types of data and the industry they work under. Another value of the hub is that software tools or applications can be integrated into this architecture to provide advancement or upscaling opportunities. Additionally, the MDM is a centralized platform which can incorporate vast types of data across different sources to assure users they are seeing the single version of the truth each time. If users do not keep up with how fast data volumes and sources grow, this could be problematic and why the MDM Hub may not be useful. Another non-value is how software tools are to be integrated in any one of the models because of constant updates, version control problems, and often regular system-wide maintenance. This would be a hit in productivity because of adjustments to be made, and if software is not used properly or is not always up to date, then there is wasted money because applications running on the systems are not being utilized to their full potential. The Snowflake schema is another schema database model that is based off the star schema, but is more expansive in terms of the number of dimensions it can have. There is a fact table and dimension tables, which are not entirely normalized. It works the best in data warehousing because this concept requires making more tables with new categories over subcategorization from categories already made. Because of the abilities of the Snowflake schema to allow normalization, data warehousing is in a hybrid style where there exists some patterns to address real-world problems, helpful for detecting trends with past or present data, and using such metrics to forecast potential outcomes. Detecting patterns will help users get more information and eventually knowledge from the data, because users will have a better understanding of overall architecture of this data model. This model adjusts the growth in data and categorization and breaks down each classifier into other information that the star schema cannot effectively show to users. The diagram in this slide shows a more expanded entity relationship diagram compared to the diagram for the star schema. Notice how this is more expansive than the star's architecture by breaking down each category into their own tables in connection with the primary data reference table. One of the values that can be useful with the Snowflake schema is that there is order when categorizing data because of static attributes needed to classify the data. Another value of Snowflake is its normalization in comparison to other data models because performance metrics can be retrieved from this schema for reports or evaluations. Thirdly, the links made between entities are explicitly separated from other tables because of the hierarchical breakdown of the relationships in the data system. Like the MDM Hub and star schema, regular maintenance is required on systems in this style to update data tables and to adjust higher data volumes. Should users want to access the systems during weekends or when few to no users are online, such events will be an inconvenience to viewing what they need. The other values that users will not get out of this are the performance and speed of querying data, the cost to extend and expand its potential life cycle, and the complexities of doing analysis on many details from the data. The more complex the model gets, the harder it may be to get the system to adapt to massive changes. A data vault can help a company determine the uniqueness in structuring data when needed. It is an ensemble model which contains some elements of the 3NF and star schema models to allow a data architecture to have the opportunity to grow over time with data users work with. Using this model can help add more value to their company with decision-making, supporting their customers' needs, and even prioritizing data as a key asset. There are three key components of a data vault model: at least one data hub, links to all tables and attributes, and satellites ensuring the connections are stabilized for the best performance. The data in this model is all important. A data vault requires detail and focus by breaking up attributes for a given number of categories and pointing out which data tables are more important than others. There is also focus on metadata, or data about the data. This information can prove to be helpful for further understanding the data, how it is structured, and where it can be used to apply knowledge. The diagram on the right shows how a data vault is to be visualized. It contains elements of an MDM Hub, star schema, and 3NF models all incorporated into the design. The red-colored cells in each table have metadata which describe what data the table contains and how their content stands out from that in other tables. There are many good values out of the data vault. The first is that metadata is important to the system because it will help provide the company more value and opportunities to do more with their data, and make better informed decisions. Such would be useful for big data projects and business intelligence applications and solutions because there is structure to the data collected. This would help with setting goals, meeting regulations, and making data cleanup and protection easier for all users. Because more can be done with this model, for those in parallel computing, the Data Vault can take on more tasks for querying, collecting, and extracting data. The Data Vault does, however, have shortcomings. The long-term plan must be made ahead of time for it to be fully effective in the workforce, and the data must have some structure as a base to show some organization beforehand. While great with finding real-time data, this might not be helpful for looking for its history because of its present and future-minded potential. With regulations in place, it can also be hard sometimes to get immediate access to this data, but information from its categories and subcategories can prove for this to be a powerful master data model. We discussed in this analysis that there are 5 different master data models that a company should consider: Star Schema, Third Normal Form, MDM Hub, Snowflake Schema, and Data Vault. Each of the master data models are similar in some ways but different in others. Each had their own strengths, weaknesses, future potential, and overlapping values that could either be valuable or not valuable to any users in a company. It provided for this company to consider how they are managing data now, but also focused on what long-term future benefits that any data model could have. Users should have some understanding of data models they work with and its functionalities, but the technical opportunities each of them have for growth are endless. The trends around us for cheaper, faster technologies are imminent and can help businesses be more productive and open-minded with how they use data. It is expected that these models lack different capabilities, but how they are used depend on what vision one has in mind. Any data model implemented is not a one-size-fits-all decision that would prove to be successful in any company. It is a case-by-case basis because data models portray their strengths and weaknesses with the data that users work with. Employees, stakeholders, and company leadership are expected to come to agreement on what data models they should consider implementing. There are different issues that a company must consider: the cost of hardware and software, the number of employees to be using the system daily, and how much maintenance needed are just a few of the questions that may be brought up. Communication is key before implementing any new or additional master data model. The truth is, any master data management model can fit in any company. One model might work now, but the more data it collects and stores, this original model might not be useful in keeping up with the changes in the history that only gets longer. All of this is dependent on the kind of data that company collects, how they match up with their competition in their industry, and what they have now that they can either continue to use or phase out and spend on new systems to keep everything in place. May we move forward with approval of a plan to implement more than one master data model plan? I propose that there be at least 2 master data model plans that focus not only on present data benefits and issues, but also how this data model can evolve into the future. Having 2 models would not only focus on how data is collected within the next 5 years, but also considers what the company can do with its data in 10 years and thereafter. The first data model in place should be the star schema because it is generalized where all users understand how their data is structured. This assures the notion to keep it simple in as many situations as possible. The first goal for a company and its employees working with data is to understand what works and what does not work for them. Keeping it simple is always key, but while that is a challenge, generalizing where data is located can help provide guidance on where to be productive. A contingency plan requires either using any one of or both of the MDM Hub frameworks or working data vaults. Any one of the 4 data hubs listed in this analysis will be suitable because there will become a time when data that a company accepts will have to change its framework and software used to decipher through a large volume of data. Data vaults, on the other hand, are helpful to further organizing data and even helping with creating metadata. It will help create a more robust system for data access, which can help a business better use its data for strategic purposes and will keep a standard for making sure that this data is being managed and regulated effectively and with excellence.